Today we're diving deep, literally, into a fascinating volcanic mystery that's been hiding right under our noses, or more accurately, under the waves of the Mediterranean Sea. Picture this: the beautiful Aeolian Islands just off the coast of Sicily, Italy. They're famous for their stunning beaches, charming villages, and of course, their active volcanoes like Stromboli. For centuries, we thought we had a pretty good handle on the geology of this place. The story went something like this. These islands are part of a volcanic arc, a curved chain of volcanoes formed because the African tectonic plate is diving or subducting underneath the Eurasian plate. It's a classic geological setup we see all over the world, like in Japan or the Andes. This subduction process melts rock deep underground, creating magma that then rises to the surface to form volcanoes. Simple, right? That was the textbook explanation for decades. But what if I told you the story is a lot more complicated and a lot more exciting? Recently, a team of scientists decided to take a closer look, not just at the islands themselves, but at the seafloor surrounding them. Using high-resolution sonar, they mapped the seabed in incredible detail, peeling back the layers of water to reveal what lies beneath. And what they found is completely rewriting the geological history of the region. They discovered a massive, previously unknown volcanic field right on the seafloor. We're not talking about a couple of small cones here. This is a huge, sprawling complex of ancient volcanoes, lava flows, and domes stretching for miles. The most mind-blowing part? It's way bigger and more complex than anything we see on the islands above. It's like discovering a hidden mountain range that no one knew existed. The sheer scale of this underwater volcanic landscape was the first major clue that the old subduction story wasn't the whole picture. So the scientists started digging into the data. They analyzed the shape and structure of these underwater volcanoes. One of the most intriguing discoveries was a gigantic, 15-mile-long ridge. That's like a volcanic mountain stretching from one side of a major city to the other, all hidden underwater. But this wasn't just any ridge. Its orientation, its shape, and the way it was formed didn't quite fit the classic subduction model. It pointed to a different kind of geological force at play. The second piece of the puzzle came from analyzing the rocks themselves. By dredging samples from the seafloor, they could study the chemical makeup of the lava that erupted here millions of years ago. Now, volcanoes are a bit like chefs. The ingredients they use, the molten rock from the Earth's mantle, determine the final product. Lavas from subduction zones have a very specific chemical signature. But the lavas from this newly discovered seafloor complex? They were different. They had a chemical fingerprint that suggested the magma source was much, much deeper than we previously thought. This deep source magma is a game changer. It means the melting process wasn't just happening where the African plate was subducting. Something else was causing rock to melt way down in the Earth's mantle and then rise up. This led scientists to a radical new theory. What if the entire crust in this region is being pulled apart? Imagine taking a piece of warm toffee and slowly stretching it. It gets thinner in the middle and eventually it might rip. Geologists believe something similar is happening to the Earth's crust beneath the Tyrrhenian Sea, where the Aeolian Islands are. This process is called rifting, or crustal extension. As the crust thins out, it does two things. First, it reduces the pressure on the hot mantle rock below. Just like taking the lid off a pressure cooker, this pressure drop can cause the rock to melt, creating magma. Second, this stretching creates deep cracks and faults that act like superhighways for that magma to travel up to the surface. This new theory perfectly explains the giant underwater ridge they found. It's likely a massive tear in the crust, a rift, that has been spewing lava for millions of years. It also explains the weird chemistry of the rocks. The magma isn't just coming from the subducting plate, it's also coming from this deep, rifting process. So it's not one or the other. It's both happening at the same time. The Aeolian Islands are sitting in a unique geological hotspot where two major planetary forces, subduction and rifting, are colliding. Think about what this means. It's like we've been watching a play thinking there was only one actor on stage, and then suddenly the curtain pulls back to reveal a whole ensemble cast that has been influencing the performance all along. This discovery forces us to rethink how volcanic systems work, especially in complex areas where multiple tectonic plates are interacting. So, what are the implications of this? For one, it helps us better understand volcanic hazards. Knowing that there's this massive, complex plumbing system beneath the waves changes how we assess the risk of future eruptions. Are these underwater volcanoes still active? Could they erupt? These are the critical questions scientists are now asking. Mapping these structures is the first step toward monitoring them for any signs of unrest, like small earthquakes or changes in gas emissions. It also tells us an incredible story about the Earth's history. The seafloor is like a geological history book, and we've just turned to a chapter we never knew existed. By studying the age and progression of these lava flows, scientists can reconstruct how this region has been torn apart and reshaped over millions of years. It provides a window into the powerful, slow-motion forces that build mountains, create oceans, and drive the very engine of our planet. This is what makes science so thrilling. You start with a simple question, you go looking for answers, and you end up discovering a whole new world you never imagined. The hidden depths of the Aeolian Islands have shown us that even in a place we thought we knew so well, there are still profound mysteries waiting to be uncovered. The Earth is constantly surprising us, reminding us that there's always more to learn. So next time you see a picture of a beautiful, peaceful island, remember that beneath the surface, there could be a dramatic, fiery story of tectonic battles and hidden volcanic giants, a story that's still being written. Thanks so much for joining me on this deep dive today. If you found this as fascinating as I did, make sure to hit that like button and subscribe so you don't miss our next adventure into the world's most amazing scientific mysteries. Drop a comment below and let me know what you think. Until next time, stay curious.